All right, so welcome to Communicating Science to Solve Tough Challenges, Week 8. We've made it to Week 8, and I'm really proud of how far we've come because in our discussions, I can tell that we're getting a lot greater sense of science communication. And so now that we've talked about science communication for 7 weeks, 7 different lectures, this lecture we're going to talk about using science communication to shape policy. And I realized that this differs between different nations. Like we have a lot of international people in our course. But this is focused mostly on US policy, but it can apply to any policy situations. The general concepts, I think, can apply to most nations. All right, so let me get through the slide. So, okay, last time we learned that the brain is wired for storytelling. We talked about the power of stories to communicate science, and we talked about 2 storytelling techniques, including the hero's journey, in which a hero goes on a voyage, and the and but therefore model. So today, as I mentioned, today we're solving problems with science communication, communicating science to shape policy. So I've been kind of doing a deep dive into science policy myself because I've been recapping. I was a journalist covering the AAAS meeting, which in the US, it's the American Association for the Advancement of Science. And they basically talk about different aspects of science policy, and they do federal lobby, the federal advocacy, and they're also trying to branch into local advocacy. They also have an international component, but mostly focused on the US. But I've been learning a lot about the ways that science is used to shape policy. And I've learned that, so I was listening to a talk by Karen Akerlof, who's at, I forget where she's, like outside of Washington. And she was saying that, sorry, my headphones are being weird. When you think about the ways that science is used in Congress, there's some committees where they use a lot of science, like environment, science itself, natural resources, I think was another one. And 90% of the time when science comes across their desk, they actually do look at it, engage with it. But the ways that they use science are different. So they usually use science to support existing policies. It's relatively rare for policymakers to use science to inform a completely new policy. And they looked at the science and technology policy fellows, who are basically scientists appointed to working in sorry, my headphones are giving me grief. So, but basically, they found that whether you're a scientist in a scientist fellowship position or you're not a scientist, you're just an everyday staffer, maybe have a government background or a political science background, you use science in the same ways. 70% of the time, it's just to fulfill an existing policy goal, and only 30% of the time is it creating an entirely new policy based on the science. So, but 90% of the time, when the science comes across their desk, according to Akerlof, um, it gets looked at. So science is a huge piece of the puzzle. But there's a problem there. Congress faces a scientific disconnect. Most people elected to Congress are government and political science majors and lawyers. There's few engineers and scientists in Congress. I talked to Suchita Champak of Rio, and she's in India, and she said the same is true for Indian politicians, is like few of them are actually like scientists. They're mostly politicians. So as a result, problems don't get solved in the same way we might solve them as scientists and engineers. So, because scientists and engineers have like a problem solving mindset, like that's their job, to solve problems, to create. Engineers, I find to be very, very applied. But and policymaking is applied too, but the perspectives are different, and the background of most policymakers is not a science background and not an engineering background. They don't think in terms of solving problems. So I think I had someone actually just told me that recently, and I was just like, so true. But in the US, nonprofits have established prestigious congressional fellowships to put scientists in an advisory role. As I was talking about, here in the US, we have the Science and Technology Policy Fellowships, but that's not enough because these often require PhDs and they're super competitive. Sometimes one person per year for the entire field of neuroscience, for example. Are I think for all of so I think there's like 2 congressional fellows for the main fellowship program per year out of all of the people that apply, which is like 2 people is not enough to change to help science be better infused into the process, because that's one of the bottlenecks is that no one few people know the actual science knowledge, so the science issues don't get dealt with. So the problems, the solutions aren't as good as they could be if scientists were helping out. So my solution is to get scientists engaged with policymakers, and it's different every place. Obviously, it depends on your government. It's easier in some governments than others, but here in the US, and you have to learn to think about where does your science funding come from? In the US, almost all academic science is funded through government funding approved every year by Congress's Appropriations Committee to the National Institutes of Health, National Science Foundation, NASA. This reveals that problem that I talked about, though. Most science do not, most scientists, most scientists do not know how to talk to policymakers. So when I worked in Congress, so I worked in Congress in early 2017, and I learned a lot about communication from that experience because in science, I had just spent a decade as a scientist. And, you know, in science, we talk very matter of fact. We only spout facts. We don't really, we talk about the facts and we value the facts because we're scientists. And so that facts are our bread and butter. But in the policy world, it's all about personal stories. So I came up with some examples. So in science, I might say, we did a systematic study of 500 people with post-traumatic stress disorder, PTSD, and found such and such life impairments. And actually 500 people is a lot. So that would care a lot. That has a lot of statistical power there. So now let's go to the policy world, talking about the same topic of PTSD. Ever since, you know, Colonel so-and-so got back from the Iraq War, life hasn't been normal for them. They saved their best friend's life, but then they came back to the US and they can't find work. Their wife left them. I mean, like in the policy world, they don't really say that. They would say something like, thank you for your service, for sacrificing Mr. Colonel so-and-so. I mean, these are kind of in alignment, but that's not always the case. Because like when you're in a policy, like you're running for office, the stereotype is you're kissing babies, you're getting to meet people, you're looking them in the eye, shaking their hand, saying, I'm learning about your experience. I value your personal experience. But in science, the thing to do, it's not kissing babies. It's like going to the lab, finding data. So yeah, my examples aren't that great, but I'm trying to show you that these are somewhat in alignment. These particular examples that I came up with are somewhat in alignment because PTSD is in fact very medical and very scientific. And so there's a lot of science there, but that's not always the case. And I don't know how much you guys have been following the Chips and Science Act, but it was signed into law in 2022 and it created a domestic semiconductor infrastructure because for 2 decades, we did not have a domestic semiconductor infrastructure in the US because they moved it overseas because it was cheaper to make them overseas. So now we finally brought them back to the US because of COVID and the kind of rollback of globalization that happened due to COVID shutting everything down. And so I was listening to a speech by the president, Joe Biden, and he was talking about chips, but it was interesting because he didn't talk about the technology of the chips at all. He was just talking about like more jobs, like everyone's going to have more jobs creating semiconductors. Everyone's going to have the best technology. We're going to get rid of disparities and make the world more inclusive in the tech industry. And it was kind of about our like daily lives more than it was about like, oh, look at this processor. It has a very specific processing capacity. Like this is the one we need. Like this is the best processor. We have that. I mean, like there was a little bit of that as well, but it wasn't about the science. It was about the people. It was about what's in it for me is another concept I learned from covering the AAAS things. Is like when you're trying to talk to a policymaker, you always have to think what's in it for me. And the science, if you just say specific science facts, you don't tell them what's in it for me. So here's another one that I tried to come up with. And honestly, I came up with these slides really quickly. So in the science versus policy world, so there was a thing that happened. There's a lot of kind of I want to say they're not natural disasters. They're more like environmental disasters. So like Flint, Michigan had the lead in their drinking water. And actually, as far as I know, they still haven't like really fixed that. And then there was the trail derailment in East Palestine, Ohio, that actually released a bunch of like toxic chemicals into the air. And so developmental neuroscientists, when they talk about toxins, obviously toxins are very serious, especially for children that are very young because young brains are developing and they need to have very good environment. So obviously developmental neuroscience would talk about the research, and other scientists would find that really compelling. But I think if you told a policymaker, I mean, maybe because this is kind of like an applied situation, it's like people's brains, people's brains are very important for bajillion of reasons. But if you just came and like gave them a study, gave them a like research paper, and you're like, here, read this. Like this has everything you need to know about like why it's bad to like have toxin exposure as your kid, versus like talking about like some like good, when you have the State of the Union, they have like some family there, like, oh, this is so and so, they were a victim of lead poisoning, or you know, whatever environmental crap is happening, because it's actually a huge problem, because I, for some reason, no one cares about this, even though like if it happened in their backyard, they would care about it a lot, because they do know what the stakes are, but they don't. If they had the scientific backing, scientists would say like, heck no, we cannot have lead whatsoever in our water. But like policymakers, they don't, they're sort of like, it's not, I don't know why it has gone on, these things keep happening, because you would think policymakers would pass legislation to get rid of that, because that's so important for health. But maybe they don't think about their health, because all they're doing is just like, you know, being hardcore and maybe not neglecting their own health. But that's why we need more scientists in policy, because of things like this. So here's another one. These are really hard to come up with. You really have to spend some time in the policy world to like get the feel for it. Like next time a politician's giving a speech, just like listen to that person and see what they're saying. And then like when your colleagues are talking, listen to them, and it's like so different. Like so science world people, they will say some science stuff, and then the scientists like, to scientists, like that's it. Like that's the explanation. That's like the whole, the as Shakespeare says, there's the rub. Like that's it. But in the policy world, they are better communicators. So they actually have to take the time to communicate things like what's in it for the constituents, why people should care about this, why they're working on it. So anyway, to summarize everything I've tried to say and hopefully communicated okay, is that politicians communicate on a personal relational level. They think about personal relationships. They are very much about like personal stories. Scientists are but to scientists, personal stories are anecdotes. So scientists often speak in broader terms about truths about things and people they have gained from their work. Politicians are storytelling pros. Like just think of all the most like landmark speeches you have heard. Like Martin Luther King's "I Have a Dream" speech is obviously iconic. John F. Kennedy's speech about going to space. There's a lot of really good political speeches from all over the world that are very iconic, and they're good because they use rhetoric, which is like a way of this different fundamental principles of speaking, appealing to these different Greek things called ethos, logos, and pathos that relate to experience, evoking emotion, reasoning. Scientists don't really get training in that, but politicians do. Not only do they probably get some training in that, maybe even if they don't, they have to give speeches, and they're constantly in contact with people. So scientists think the facts speak for themselves, and to scientists they do, but to the rest of the world they don't really. And politicians are masters of politicization of facts, and scientists can try to correct the politicization all they want, but by the time they start doing that, it's too late. Like, I don't know how much you guys are following the select committee on COVID. They actually called Anthony Fauci to testify to Congress, and I guess they got him to admit that social distancing was just something that like they came up with or something. So there's this whole like postmortem happening with COVID, and actually I think they're kind of finding a lot of things. Like I read this article in the Washington Post. It was by a woman that works at the Harvard and MIT, and she was talking about how COVID, the origins of COVID and all this stuff. So that would have been a great conversation to have like in the pandemic. But for some reason, the two policy world, the science world and the policy world, just were completely on different levels. Anytime they tried to, you know, they didn't ever combine because the politicians, they demanded answers. The scientists kind of were a little bit hostile to them. And then it's kind of they became adversarial almost, like the NIH versus like the like this committee that's investigating them. So it's really important to learn about communication and know about these things. And it's kind of like an art to be able to balance all of these different questions that people are asking about COVID versus like, what's the science? Like, what do people care about? Like, what can we tell people to answer their questions, like in a way that actually resonates with them? That's, as we saw, it's a very difficult challenge, but it's a very needed thing to tackle. So that's why we're talking about this today. Okay, so science communication is foundational to sound science policy. Obviously, it's important to be able to explain the science to Congress or to any legislative body, any governing body, not just Congress, other judicial system, what's the other one? Executive branch. Scientific and technological challenges the world faces includes environmental sustainability, global health, high-tech manufacturing. Did I talk about semiconductors? I think I didn't talk about semiconductors, but I was writing an article about them yesterday, so all of my memories have blurred together in my head today, but that's okay. Agriculture, food insecurity, science diplomacy amidst two wars, and so on. So that was all I had to say today. That was quite the ramble. So I look forward to engaging with you in the discussion. Let me stop the recording. Hold on.